The explainer. Today, we are tackling a really critical transformation. We're moving completely away from that junior developer mindset. The one that just asks, okay, how do I make this code work? And we're stepping fully into the senior architecture mindset. Because when you're interviewing for a senior engineering role, the expectations shift dramatically. You aren't just writing code anymore. You're designing systems that need to outlast you. So consider this explainer your definitive guide to decoding the most critical API design interview questions and really figuring out what your interviewers are actually looking for.
To nail this, we need to use what I like to call the translation framework. See, when an interviewer throws a standard API design question your way, they almost never want a textbook definition. What they're actually asking is, can you design for scale? Can you design for long-term evolution? And crucially, can you anticipate and mitigate inevitable failure? They really want to see if you grasp the practical, real-world consequences of your architectural decisions. So every single answer we construct today is going to be filtered through this exact translation framework.
Here is our roadmap for today. We're covering 4 critical pillars of API design: core REST principles, evolving without breaking, rate limiting, and system observability.
Let's dive into pillar number 1, core REST principles. And the real question here is, do you know when to deviate?
When someone asks how you design a RESTful API, they're checking to see if you can apply core principles consistently. Notice the amateur approach on the left, throwing in verbs like get users or using singular nouns like user/123. We need to absolutely strike that from our vocabulary. The senior approach relies on the strict, consistent use of plural nouns. Every entity is a resource, so it's /users, never /get-users. And you design your URL hierarchy to naturally reflect resource relationships like /users/123/orders. A quick pro tip for you here, definitely limit that nesting to maybe 2 or 3 levels. Anything deeper than that strongly suggests your resources are just way too tightly coupled.
Now, that consistency extends directly to our HTTP methods. To keep your API perfectly predictable, you've got to map your methods cleanly to standard CRUD operations. Get is for reading, and it should always be cacheable. Post is your go-to for creating new resources. Put is for full, complete updates, and delete is, well, for removing resources. Using these correctly, along with sending the precise corresponding HTTP status codes, is absolutely essential for your API's overall usability.
Which brings us to a huge constant: idempotency. This is a massive buzzword that interviewers absolutely love, and it gets heavily tested, especially in financial API design. Idempotency simply means that making the exact same request multiple times produces the exact same result as making it just once. Let's contrast 2 of the methods we just talked about. A put request is idempotent. If you update a user's name to John 5 times in a row, the end result is exactly the same as if you did it once. But a post request, not idempotent. Calling it 5 times creates 5 brand new resources. Grasping this distinction is totally vital for preventing duplicate operations during network retries.
All right, moving right along to pillar number 2, evolving without breaking. This is all about the true cost of change. When an interviewer asks you about API versioning, what they're really doing is testing your grasp of long-term system maintenance. You generally have 3 main approaches, and they each come with their own distinct trade-offs: URL, header, and query parameter versioning. Now, header versioning, like what GitHub uses, is semantically much cleaner, but honestly, it's harder to cache and a pain to test. Query parameter versioning keeps the path clean, but it's super easy for developers to forget. But look at URL versioning, sticking a v1 or v2 right in the path. Yes, I know it is philosophically impure because the version is acting as a resource identifier, but practically, it's excellent. It is the most common, the most visible, and it's super easily handled by your routing infrastructure. But honestly, regardless of the versioning style you end up choosing, you have to follow the golden rule of backwards compatibility. Burn this quote into your memory. Only make additive changes within a version. Adding a new field, a new endpoint, or an optional parameter, totally safe. But removing a field, changing a field type, or altering the core semantics, that is an instant breaking change. If you pull a field out, you will instantly break client integrations. You have to rely on the tolerant reader pattern, where your clients gracefully ignore unknown fields and your servers accept missing optional fields.
Now, if you really want to blow the interviewer away, bring up the gold standard, the Stripe approach. Stripe does not use massive, disruptive v1 to v2 jumps. Instead, they version by date. Every single API request specifies a date. and the server runs that request through a chain of internal version transformers to match the requested version's response. It is a brilliant strategy that prevents those giant, painful migrations and allows for highly fine-grained, continuous evolution of the API.
Let's hit pillar number 3, rate limiting. We're talking API resilience and abuse prevention.
The hidden question behind rate limiting is really, can you protect your API from bad actors without punishing your legitimate users? Interviewers are going to want to hear about specific algorithms, and you should immediately drop the token bucket algorithm. This is the industry standard. It's used by AWS, it's used by Stripe, and practically most major API gateways. It works exactly like it sounds. Just imagine a bucket that fills up with tokens at a steady, constant rate. Every request costs 1 token. This setup allows for a smooth, steady rate of requests overall, but uniquely, it permits controlled bursts of traffic up to the maximum size of the bucket. It is just brilliant in its simplicity and efficiency.
But here's the catch. You can't just rely on a single global bucket. You need a comprehensive multi-tiered defense architecture. You're going to need per-user limits to handle different pricing tiers. You need per-endpoint limits, because obviously a heavy database write should be way more restricted than a simple read operation. You absolutely need global limits to protect your entire service from just completely melting down, regardless of what the individual user limits are. And finally, you throw in IP-based limits as a catch-all for any unauthenticated abuse.
And that brings us to a universal truth of system design. Unbounded lists are a literal ticking time bomb. If you do not paginate your API responses from day one, I promise you, your database will eventually be destroyed by a single massive query. Always, always paginate. And to really add that senior touch to your answer, advocate for cursor-based pagination over offset-based pagination. Offset-based pagination breaks down when items are inserted or deleted, but cursor-based is incredibly stable and so much more performant for large dynamic datasets. Finally, we arrive at our 4th pillar, system observability. Getting true visibility into failure at scale. Observability really answers the question, can you build visibility into how your API actually performs when things inevitably go wrong? And it relies on 3 main pillars. First up, metrics. This is your time series data showing request rates, latency, and error rates. Second, logging. Your logs must be structured JSON for easy machine parsing, and crucially, they must never, and I mean never, contain personally identifiable information, or PII. Third is distributed tracing. When you're dealing with a complex microservice architecture, you have to be able to track a single request from the API gateway all the way down through every single downstream service.
But observability isn't just about passively collecting data. It's about holding yourself and your system to a standard. You need to set hard numbers, like targeting 99.9% for your service level objectives or SLOs. And this number isn't just for show on a dashboard. It actively dictates your error budget, which in turn determines how aggressively your engineering team can actually deploy new changes. Because if you burn through your error budget, feature deployments stop entirely, and the focus shifts 100% to reliability.
Which leads us to a vital security point for when things break. And trust me, they will break. When an unexpected server error occurs, never leak internal details on a 500 error. Never return a stack trace to the client. Never return a raw database query. Doing that literally hands attackers a treasure map to your internal infrastructure. Instead, a 500 error should only ever return a generic, polite message, along with a traceable request ID that the user can hand over to customer support.
So we have covered core REST principles, the golden rules of backward compatibility, robust rate limiting, and deep observability. But all of this theory leads to one final, provocative question that you really have to ask yourself. Will your API actually survive contact with the real world? Look, it's one thing to design a perfect, pristine system on a whiteboard during an interview. It is an entirely different beast to build a system that gracefully handles unpredictable production traffic, massive scale, and malicious actors. If you keep these pillars at the forefront of your mind and apply that translation framework, you aren't just going to pass the interview, you are going to build APIs that truly endure. Keep learning, stay focused, and we'll see you in the next exploration.